Hi everybody. Let's go ahead and get started. Just a quick reminder for you before we begin. You do have an assignment coming up. I think it's due on Thursday, Tech Jobs. The first assignment of Unit 3 is due this Thursday. So hopefully you've been making progress on that. If you need some help, be sure to let us know, let your TA know, let me know. Be happy to help you out with whatever you need to get that assignment in by the due date of Thursday. I think that's all that I have on my radar as far as announcements and upcoming things on the schedule. So let's go ahead and talk about today's material. It's actually a big day. We introduced you to lots of important concepts, actually. The biggest one being Spring. Whoa, sorry. Okay, the biggest one being Spring. So yeah, before we talk about Spring though, let's talk about some of the other stuff that was introduced today. Some of this is a little bit of review, but some of it is kind of new as well. Who can tell me what a breakpoint is? What do we use breakpoints for? Yeah. Yeah, you. Kind of like a bookmark? Sure, I could see where you'd make that analogy. Yeah. Yeah, it's where we're going to use it to stop our program execution. And then we can do all kinds of cool stuff when our program is stopped, right? I mean, have you ever, maybe you've had this thought cross your mind, like, oh, I wish I knew what this value was at this point in time. Well, with a breakpoint, you can do exactly that. I can stop the program at that point, and I can see the values of all of my variables at that point in time. So it's a very, very, very powerful technique used with debugging, which is not something that we've actually had a lot of access to lately, although we did see it back in Unit 1 with the textbook, the Python textbook online, that they called it Code Lens. It's a debugger. Every other tool that you're going to see like that is called a debugger. That's what Code Lens was. IntelliJ has a debugger in it, and we're actually going to take a peek at the debugger and show you some stuff with the debugger a little bit later on today. And so once we set a breakpoint, we run our program, it stops us there. What are the options that we have in terms of controlling our program at that point? What are the different things that we can do? There's 2 or 3 main things that you might be interested in doing in terms of controlling execution of your program. You can step in and step out. So when I say in and out, what am I stepping into and out of? Methods, yeah, methods. So I can step into a method, which will take me to that method, and then I can walk through that method of code. If I decide that I actually don't want to be in that method anymore, I can step out of that method, which will take me back to wherever that method call was, right? And so it allows us to traverse through our program and see exactly step by step what's happening in our code, and we can watch the variables change over time and see how our code is operating, hopefully to either help us understand what's happening or figure out why our code is not running the way that we expect it to. Cool. If I don't want to step into a method, there's actually another option I can use. Step over says, I don't care about that method, which is actually pretty useful if I feel like the method in question is fine, like I'm not worried about it, or if it's not my method, right? If it's a method from a Java library or a Spring library, I'm not going to worry about what those methods are doing. I'm just going to have to trust them that they're doing the jobs that they have set out to do, so I'm not going to worry about stepping through those particular methods. I'm going to worry about stepping through my own methods. All right, cool. We also had some Git stuff on the agenda today. We've seen Git Ignore files before, but they were covered in the prep work today, and I think it's an important concept to be aware of. So what does a Git Ignore file do for us? What does a Git Ignore file do for us? Yeah?
You put in there files that you don't want to keep track of change.
Yeah, so if there's anything that I don't want to keep track of, anything that I don't want to be part of my repository, I add that to the Git Ignore file, and then the next time I add everything or make a commit, it will leave those files off. So why is that a good thing? What are some examples of files that we might want to ignore? Mm-hmm. Yeah, exactly. So you mentioned IntelliJ settings. Actually, almost anything having to do with IntelliJ, whether it's user settings or project settings or other kinds of stuff to do with IntelliJ, is stuff that we usually don't want to keep in our repository, because if somebody else were to grab that repository and load it up, like you said, we don't want our settings to get in the way of their settings. They've already got their IntelliJ set up the way that they like to use it with the settings that they prefer. So we don't want to mess with their stuff. Yeah.
So if you add something to Git Ignore, then is it gonna like just not even show up in the staging menu?
So the question was, if you add it to Git Ignore, will it show up in the staging menu? I think that, the answer is either no, it will not, or I can't remember which one it does. We could maybe do a little bit of a test of this later. It might say these files were not added because they were ignored. I feel like I've seen that before.
Seems like when we updated that Git Ignore and they added a couple in the video,
Mhm.
they added it, it
Kind of disappeared, yeah. I mean, either way, you can always see those files, right? The files are still there. You can still change them and use them on your computer all you want to. We're just telling Git to ignore them, not your computer to ignore them. Any other kinds of things that you might want to consider putting in your Git Ignore file? You can think of sometimes dependencies. Can you elaborate on that?
The actual libraries themselves, like Gradle is for building,
Yeah, so Gradle's on our list of things to talk about, but you've hit a very good point, right? Gradle is managing dependencies. That's what it is. It's a dependency manager. And so what Gradle does, and you saw this when you loaded up the prep work, one of the first things that happens is it goes online and it downloads a whole bunch of stuff, right? All of the stuff that you need to run your program. We don't want to put that stuff in your repository, because part of the nice thing about having Gradle is that if somebody else wants to use your code, if they have the Gradle file, it can go out and figure out what files they need, because they may already have some of them, or some of them may not work quite the same way on their machine as they do on your machine, right? And so Gradle's going to solve those problems for us. We'll talk about that a little bit more later, but you're exactly right. So if we want to generalize Git Ignore files, there's actually a good general rule of thumb, right? You should ask yourself, if you're adding something to a Git Ignore file, which is this file specific to my computer, or is this a file that I would want anybody to see if they were running this project, right? If it's something that is very specific to your computer, it's dealing with your settings, dealing with something that you downloaded just to use on your machine, you probably want to slap it in your Git Ignore file. But for things that are necessary for your program to run, like the code that you write, the Java files that you create, we don't want to ignore those. That's the good stuff. That's the stuff that people are going to need to run your program. It takes a little bit of practice, a little bit of trial and error. It happens all the time where I'll download a repository and it's missing some very important file that I need to run the code because they ignored it on accident. Happens all the time. It'll happen to you as well at some point. But with a little practice, you'll get better at it. A couple more Git related things. What is a Git remote? I know we've talked about this before, but we're getting into Git again, so it's good to review these concepts. What's a remote? Yeah, no, that's exactly right. It's a place where your stuff is stored, but it's not on your computer. It's somewhere else. It's on the internet. You could say it's in the cloud if you want to sound fancy about it, which is not wrong, right? So a remote is a version of your code, your repository that is stored on the internet. And so when we say remote, for our purposes, we're talking about GitHub. It doesn't have to be GitHub. There are actually lots of other websites out there that you can use for this purpose, but GitHub is by far the most popular one, the one that you're going to see most often. So when you say remote, you can usually think GitHub, and you're probably not going to be wrong. It's important to realize, though, right, that you've actually got multiple copies of that stuff flying around. There's one on your computer, and there's one on the internet, and they may or may not agree with each other. They may or may not match up. And it's your job as a developer now to make sure that when you make changes to a repository that they do eventually match up, which means that how do we communicate with the remote? What are the operations? Push and pull. You've been doing those a lot. We had you start doing those in Unit 2, and guess what? We're gonna have you keep doing them in Unit 3 as well. It's good practice. When you do push and pull, you're either sending stuff to the remote or getting stuff from the remote to keep them in sync with each other so that they don't get in disagreement. Because when they get in disagreement, that's when we have conflicts, which are very fun to take care of. If you haven't experienced a conflict yet, give it a little time. It'll happen. And we'll be here to help you fix it when it does. All right, cool. Last Git-related item on our agenda. What is an upstream repository? Upstream repository.
Is it a repository that's set where you push to?
So the question was, is it a repository where you push to? And the answer is not necessarily. Yeah.
So on the upstream repository, if you update anything that we need to know that needs to flow down to us, that's how we get to it.
Yeah, so you're getting us closer to the right answer here. So we're talking about multiple repositories. We've got our repository with our stuff in it, and then there's an upstream repository, which is maybe where we started from. How do I create our repository from an upstream repository? What's that called? Fork. It's called a fork. So when I create a fork, what am I doing? I'm saying, well, I want my own copy of this repository to do whatever I want with it, right? I'm not touching your copy. I'm leaving your copy alone, but I'm making my own copy that I can manipulate and do whatever I want with. And so that repository that I created the fork of is my upstream repository. And that's important because let's say that later on down the line, whoever owns that upstream repository makes some changes to it or finds a mistake and they want to fix it. I can then grab those changes from the upstream repository because I have created a fork of that repository. They are linked. They are linked together. They are connected. They know about each other. And this is a very common thing that happens. Yeah. Are there any questions about the Git stuff before we hop into Gradle and Spring? Yeah. Good question. Is a fork the same thing as cloning? Can somebody describe the difference between a fork and a clone for me? Because they do feel very similar, but they are a bit different. Can somebody describe the differences? Yeah. So you're right, yeah, when you make a fork, I'm making my own personal copy, and when I make changes, I'm making changes to that personal copy. Whereas if I am cloning something and I make changes to it, it is gonna update the copy that I made the clone of, which I know maybe doesn't quite clarify the difference between the two necessarily. The word fork, if you interpret very literally, right, you can think of it as a fork in the road, right, where here's my timeline as time currently exists, and now I'm creating a fork where this is my own personal timeline, and then your timeline keeps going in this direction. And then I can create clones of either branch of that fork, which are just ways of me grabbing a copy of a remote repository and putting it locally on my computer so that I can load it up in IntelliJ and run it or make changes to it. But then eventually I'm going to commit those changes, push them back up to the remote, and that's actually going to change the remote copy as well. So you can think of the remote copy as sort of the gold standard, right? It's the version, the definitive version of your repository. Anybody can come along and make a fork of it, which is creating a new standard version, right? It's their own personal standard version, and then they can make changes to that. But a clone is simply a way of communicating that you want to grab a copy of that remote and use it on your personal machine. Whereas a fork does not necessarily do that. A fork might just make a copy in the on GitHub on the remote. It doesn't actually pull a copy down to your machine. Does that answer your question? It is a confusing topic. It is, and I understand why you would ask. Are there any other Git questions that we can talk about while we're on the subject? There's a lot of Git terminology to get used to. Yeah.
So there's a fetch.
Yes.
What's fetch?
Yeah, so there is a fetch operation, which is actually very similar to a pull operation, but not quite exactly the same. A pull operation, actually the first thing that it does is a fetch. So the very first part of a pull operation is a fetch. But then the pull operation does one additional thing, which is that it looks at the information that it has fetched, and it looks at the information that you've got on your machine, and then it tries to combine the two together. If I just do a fetch, I'm saying go out and pull the information from the remote, but don't try to combine it with what I have yet. Maybe I want to go through it first, look at it, see if I really want to combine it, see if I want to make some changes, see if I want to do something before I try to merge the two together. So a git pull is defined as a fetch followed by a merge. And I can do a fetch by itself, or I can do a merge by itself too, if I want to, manually. I will say that I don't see people fetching by itself very often. Pull is by far the most common operation that I see when grabbing information from a remote, but there are certain situations when you might want to consider doing a fetch instead of a pull operation. Great questions. Any other questions that we can address regarding Git? I'm sure there will be some eventually. Git is a somewhat confusing and somewhat large topic, actually. We're going to keep introducing more Git stuff as we go along through the unit. If there aren't any more questions, though, let's talk about some other stuff. What is Gradle? We already touched on Gradle a little bit. I told you what it was. It's a dependency manager, but what the heck does that really mean, right? What does that mean? Why is that useful to us? Yeah, we'll get there.
And the web component,
Mm-hmm.
the developer apps and everything else, and say, hey, I want to use these things.
Mm-hmm. So if there, yeah, you nailed it. So if there's stuff that our program needs to run, so some examples you mentioned were time leaf. Actually, we had you use some dependencies when you made your Spring project. There were some words that we had you type in that box, right? One of them was web, I think, was one. I can't remember all of them off the top of my head. Dev tools, yeah. Those are dependencies. Those are things that our program needs to do the things that we want it to do. And so Gradle then actually manages those for us. Let's say, for example, that we make a project and we use the web library, which we have done, right? That's what Hello Spring did. And let's say that next week, the developers of that web library come out with a new version. Well, Gradle's going to pick up on that and be like, oh, hey, there's a new version of this out. Let me grab that for you. It just downloads it automatically, and you're good to go. You don't even necessarily notice that anything happened. Or, you know, let's say, for example, that you get your project up and running and you want to send it to somebody else so that they can run it on their machine. Or you just want to put it on a different machine that you have, right? Gradle knows what you needed to make that program, and so when somebody else wants to run that program, it will go out and find those same dependencies. It's like a checklist, right, of prerequisites that your program needs to run. To understand why it's valuable, consider the old way of doing things, which is actually how what it was like when I first. Gradle did not really exist when I got into programming, so if we needed a library for our program, what did we have to do? We had to Google it. We go look it up on the internet, we download it, and then we put it in our program. We had to do all that manually. And if a new version came out in the next week or two, well, I either had to make sure that I was reading about it online, or I I didn't get it, I didn't use it. And if somebody else wanted to use my program, what did I have to do? I had to either tell them what libraries they needed, and they would have to Google them and download them and install them, or I could try to give them the ones that I had, like send them along with the program, and hope that they would work on their machine, and maybe they would, maybe they wouldn't, and if they didn't, then what do you have to do? You have to Google them and go look them up, right? So back in the day, which was not that long ago actually, we were doing this ourselves as programmers. We were managing libraries, managing dependencies ourselves. It got to be very frustrating. People hated it, people still do hate it. So Gradle was developed to help make that easier on us. We also walked uphill both ways in the snow.
5 miles.
Yeah, that's what it was like. Are there any questions about that? Any questions about Gradle? Yeah.
You might be planning to get to this later, but I'm kind of confused about how Gradle fits in with Spring.
How Gradle fits in with Spring? Well, so the answer necessarily is that Gradle is sort of an independent entity. It doesn't necessarily rely on Spring, and you can run Spring projects without Gradle if you really want to. I think it's probably uncommon to see people running Spring projects without Gradle involved. But consider that a Spring project, like the Flask projects that we saw before, relies on certain tools that have already been created for us. And so Gradle's job then is to make sure that all of those tools are available to us when we need to use them. So I could create a Spring project without Gradle. I'd have to go out and find those tools myself and download them like I was just talking about. I can use Gradle without Spring. In fact, Gradle is used to make all kinds of projects these days, not just Spring projects, but I see it a lot when I'm making Android apps. I see it a lot when I'm making even just non-Spring applications. It's just a powerful tool to manage dependencies. So I know it's tempting to link Gradle and Spring together, but Gradle is really kind of doing its own thing over here, and Spring is just taking advantage of that. Good question. Any other questions? All right, what is an annotation? This is more Spring-oriented stuff now. What is an annotation? Yeah. It is, yeah. It's a note. A note to whom? Who are we giving these notes? Who's reading these notes? Are they for us? You could argue, I think, in some extent they're for us, but they're really not entirely for us. Who are they really for? The compiler? Spring, yeah, they're really for the system. They're for Spring. I think that's a good answer, maybe the best one that we can come up with. Spring is used for building what kind of apps? What kind of apps are we making? Web apps, can we be a little more specific? More specific still. MVC apps, we're building MVC apps with Spring, which means that we've got a model, a view, and a controller. And so far, we've actually only really seen one of those three pieces in this unit. We actually saw all three of them in unit 2, but we've only seen one of them in this unit, which is the controller. And we're using annotations so far to do things like tell Spring, hey, this is a controller, right? This is my controller. But not only that, we're telling it more information about the pieces of our controller, like what? Which is called a route. Yeah, we're using it to specify what the routes are. What types of requests can be handled, right? Yeah, question in the back. Yeah, that's an example of an annotation. In Flask, yeah, when we said app.route, yeah. What do annotations start with? How do I know I'm looking at an annotation? @sign, yeah, @sign. So when I see something labeled with an @sign, that's not an actual line of code that gets run on the computer, right? There's nothing to be executed. It's not running. It's not part of my method, right? It's describing what I want a method to be used for, or what I want a class to be used for, or what I want some part of my code to be used for, so that the compiler or Spring or some other part of my system will see that annotation and be like, all right, cool, here's a controller. I'm gonna hook up this route, make sure that when people visit the site, they get this particular thing back, right? That's what annotations are used for. And so there's one annotation in particular, we already kind of talked about this a little bit, that we use for routes. What's that one called? Request mapping? Yeah, I think that's it, right? Which is what we provide information like what route we want to use, as well as the method that we want to use to service the different routes in question. And the good news is that get and post, well, those are the same get and post that we saw in Unit 2. They behave exactly the same way. The code that we use to handle them looks a little bit different now, right? That's kind of the refrain that you're going to hear for Unit 3. Oh, hey, we've seen this before. This is the similar thing to what we did in Unit 2, but the code looks a little different. That's very much what Unit 3 is going to go like from here on out. And so get and post is one of the first major examples of that. We've used those kinds of requests all the time. We know how to handle them in Flask, and now we're learning how to handle them in Java using Spring. And so the last piece that I wanted to do today was actually kind of review the app from the prep work to go over the 3 different types of methods that you saw, get requests versus post requests versus URL segments. So the question that you see posed here is, how do we pass parameters into those methods? And so I want to talk to you about that. I've got, I believe, the code from the prep work loaded up here. I think it's even running. Not that that's even entirely necessary. And so the question is, how do I, if I want to pass in parameters, in this case, in the prep work, we were passing in somebody's name, right? How do I pass those into a GET request or a POST request, or what was the last one? The URL, I forget, the URL segment, sorry. And so we can see examples of this. I have here a method that's used to handle GET requests, right? And what am I doing to actually, that's not a good example. This is a better example up here. Sorry. This one doesn't explicitly say GET request though, right? Is that all right? If I don't say what type of request I'm using, it's going to assume that I'm using a GET request. So actually saying this is a little bit redundant. It's a little bit redundant. It doesn't hurt anything. It's not causing any problems, but it's also not strictly necessary. So which part of the code here in this particular method is grabbing a parameter? It's pretty obvious looking at it, right? This guy right here, get parameter, which is operating on the HTTP servlet request, right? And so what is this object? Well, I gotta be honest with you, I'm not really sure what that object does. I haven't looked at the code for it. It's an object that's provided to us by, what exactly? Where would I find that information? Oh, well, I can take a look up here and see. I've got this import up here telling me where this comes from. And actually, I've got imports up here for the other stuff as well. Notice that looking at these imports here, org, Spring Framework, web. Oh, hey, that's one of the things that we had you type into the box, right? When you created your Spring program. So we're using that web library for what exactly? For annotations, right? For the various annotations that we're using to mark that this is a controller, that this is being used for a particular route. So all the pieces are there, and we can even see where they're coming from. But back to the question, right? If I'm doing a GET request, I say GET parameter. What if I'm using a POST request? How do I fetch parameters from that? It's the same way. It's the exact same way, which is different than what we saw in Flask, right? Flask had a different way of accessing those parameters based on whether you're using a GET request or using a POST request. In Java, they've simplified that and said, it doesn't matter. It doesn't matter if you're using a GET request or a POST request, we're gonna handle the parameters the exact same way, which is kind of nice, right? I can write code one way and it'll work for both types of requests. That's a good thing. And so the example of that is down here. You can see, again, I have this request object being passed in, and then I simply call get parameter on that request object. How do I know this is a post? I only know that it's a post because I've told it that it's a post, right? That's the only, this highlighted section is the only thing that I have saying, this is a post request. Otherwise, it's very difficult for me to tell that this is in fact being used on post requests. The last one was a URL segment, which is a little bit different than the get and post requests that we're used to. We actually haven't seen too much of this with Flask. What's a URL segment? What does that look like? How do I pass a parameter with a URL segment? What does that look like? I think it's an annotation. So if I'm visiting a page online, right? How do I know if I'm using a URL segment? What am I going to see? Yeah. Yeah. So the parameter is part of the route. That's how I would say that, right? The parameter that I'm passing is part of the route. I say slash and then some value, which is actually my parameter. And so the way that we handle that in code, you can see the route that I have set up indicates that, right? For the request mapping, I say hello, which is the first part of the route. But then after the slash, I see that name is in curly braces. So this is indicating that I'm using a URL segment here, that I intend for this to be a parameter. Yes? Yeah, sure. Yeah. So the question was, the URL segment does look a lot like the GET request. What's the difference between passing parameters with a GET request? I see the question mark and then parameter name equals such and such, right? So what's the big advantage? It does. It looks cleaner. It makes the URL look a little bit cleaner. Is that enough to jump through all the hoops to make that happen? I don't know. That's more of a personal decision than anything else. But I can't really think of any other reason to prefer one over the other. In fact, what kind of request are we dealing with here? It's a GET request. It is still a GET request, right? So it's really just another way of specifying a GET request. It's just a different way of doing it that makes your URL look a little bit nicer. Yep. It does take a little bit of work to get it set up. So we talked about how we have to set up the route with this parameter name involved, right? And then down here, you can see that I've got an annotation path variable, which indicates that this value is being taken from the route. It's being taken from the route. Yeah, what's up? Mm-hmm. Mm-hmm. So the question was, does this have to match the name that's inside the route? And I believe that it does. You can have multiple path variables here, and if you don't have them with the same name, I don't know how it would reconcile which one is which. So I believe that they do have to have the same name. That's something that we could test, though. Just change this to be something else and see if it still figures it out or not. I'm not 100% certain of my answer. It's more of a educated guess than anything else. I'm sorry? I mean, what it would be more useful for is very subjective, right? Do you Are you bothered by the fact that you've got really long URLs that have question mark, parameter name equals, parameter name equals, parameter name equals? If that bothers you, then this is a workaround system to that. Looks a little bit cleaner, looks a little bit nicer. If that doesn't bother you, then go nuts. I mean, you can see that in practice, right, if I look at Google, what Google does, that if I can type Google, well, I didn't even have to, doesn't matter, that they don't care about using the question mark equals and equal, they don't care. So they're not bothered by it. They're using the plain old GET request as normal. But it does simplify your URLs. So if you think that people are going to be sharing URLs a lot, that might be one reason why you would want to use a URL segment as opposed to the traditional GET request parameters. Any other questions? Yeah, what's up?
Like, is there a chance of conflict with that, say, name that you pass? You happen to actually be using the route
Sure.
with something else. I guess the risk of that happening is somewhat minimized.
Sure. No, it's entirely possible. So the question brought up was, isn't there a risk of a conflict here? What if somebody types in a name that is conflicting with an already existing route? That is something that can happen. There are things you can do to mitigate that. For example, I mean, I'm expecting a human person's name here, right? So then as a programmer, I'm probably not going to make a route that uses Bill or Jane or whoever as the name of that route, because I expect those to be common entries to this route. That still may not prevent all cases of that happening, though. I can only do so much to help prevent that stuff from happening. But yeah, it's something to keep an eye out for, and I gotta be honest with you, I'm not sure who's gonna win that battle, right? If I type in a name and it could be interpreted either way, which one's gonna win? I don't know. If I were putting money on it, I'd probably put money on the route that's specified, not the URL segment, but I'm not that much of a gambling man, I guess. It's a good question. I mean, we could try it out real quick. We got time. We got a little bit of time. I do have one more thing I want to talk to you about, but now I'm curious. You got me curious. So let's copy this. And I'm gonna be vain. Oh, you can see it's unhappy with me already because I made it. It may not let me do it. Let's see. It may not let me do it. You can see it's still mad at me. It may not let me do it. I have to take this off, actually. Oh, okay, there we go. And then I can just say, well, I should make it say something else so that I know which one I got to, right? So that I know which one actually won. Okay, so I've got two routes now. One that says hello/name, and then this one that says hello/my name. Restart it real quick. Oh, I might have screwed up, but we'll see what it does. Might have made a mistake. Well, you got a few minutes here. If you want to put some bets, talk to your neighbors. Oh, gosh.
So, Doug, are you just trying to see, like, if you specifically type which request handler?
All right, yeah. Is it going to go to this one, or is it going to go to this one? Is it going to go to this one, or is it going to go to this one? Do we know? If this was the Kentucky Derby, then qualified for interference. Did it go? Oh, it failed to start because I did a dumb and forgot to stop this one. My bad. I do that quite frequently. All right, for real this time. Hopefully it won't take so long. Okay. All right, there we go. And we're gonna go to localhost, host 8080. Hello, Doug. Oh, not Doug. So that means that the explicit route that we specified wins. And remember that I get 10% cut of all action that was made, which I think is probably $0, but that's okay. Good question. We resolved that one once and for all. Any other questions? I did have one other thing I wanted to go through with you real quick. We got just enough time to do it. So the last thing I wanted to show you was a little bit of a debugging example, and I wanted to go through it with the studio from last class because I feel like there were still maybe some questions about that studio after we did it in class. So I'm going to load that up real quick and just do a quick demo of walking through that with the debugger and show you some tips and tricks. So let me open up that project real quick. For those of you who need a little refresher, the studio was the no, not the Gradebook studio, the letter counting, character counting studio, where we had a passage of text. Here it is. Here's the solution that we came up with in class. We had a passage of text, and we wanted to see what letters were appearing, how many times they showed up. And we used a hash map for this, and we eventually ended on this. We ended on this setup, which is basically says if I haven't seen this character before, set the count to 1. If I have, then increase the count by 1, which I think is still a little bit of a confusing concept. And so I just real quickly wanted to show you how you could verify this using the debugger. First thing I'm going to do is set a breakpoint. I click next to the line number that I care about. I've decided that I care about this loop, so I'm gonna set a breakpoint here on this loop. And it puts a little red circle and highlights the line indicating that I've got a breakpoint. Now, I can't use the green triangle. I now have to click this little cute green bug instead if I want to use the debugger. And once it gets up and running, okay. We are now in the debugger. I know the text is a little bit small. I don't know how to make this text bigger, unfortunately, but it's paused at this line. You can see it's highlighted. It's even gonna tell you, right? Look at that, it's telling you, here's what my array looks like. It's the array of all the characters from the text in the string. So the first one is an L. And if I step through the code, which is what I want to do using these arrow buttons, so I've got these arrow buttons here. If I hover over them, it should that's step into. Now, step into doesn't really help me here because I'm not calling any methods on this line, right? There's no methods being called here. It's just a for loop. I also have step over, which is this first one. So step over or step into on this line are going to do the exact same thing because there's no method here. There's no method being called here. So I'll go ahead and use step over, and you can see that C down here, again, I know it's a little bit small to see, but it is the letter L, the first letter. It's the letter L. And so it's going to check to see if L is in my hash map. I'm on this if statement now, and I expect this statement to be true or false. Is L in my hash map? Is anything in my hash map? Should be empty. In fact, if I look down here, counts is the name of my hash map. It says size equals 0. So there's nothing in my hash map. So if I expect this to be true, which means I expect to execute this line of code, right? This line of code right here. So I'll step, and you can see I did go inside of the if statement. Correct? If I step one more time, I now see that counts is not empty anymore. It's got a size of 1. In fact, there's a little arrow next to it. I can expand it out, and I can see that what's in it? L is in it with a value of 1 associated with that. And so I'm going to speed things up a little bit just for the sake of time here. If I keep stepping through, next letter is O, so I'm going to add O. Next letter is R, so I'm going to add R, right? E. And you can see my hash map is filling up, right? I'm interested though in what happens when I get to a letter that we've already seen before, so I'm not sure exactly how far I'm gonna have to go before I see a letter that I've already seen before. Might be a space. That's what I'm working with now, is a space. What letter am I? The hash map's getting too big. P, haven't seen a P. An S, have I seen an S? No, apparently not. U, haven't seen before. These are all brand new letters because we're just getting started. M, have I seen an M? I have seen an M. I have seen an M before, so M, the count is 1, right? I see that. So now when I step, I expect this statement to be false, so I expect to come down to the else statement. Expect to come down here to the else statement, right? So I'm gonna go ahead and step, and here I am, in fact, in the else statement, and you can see now that it's going to get the value, add 1 to it, and put it back in. So if I step one more time, I should see that the value of M is now 2. I've seen that character twice, as opposed to once. This example is maybe not the most interesting example in the world because I know that it works. I showed it to you at the end of class last time. We verified that the counts looked correct. This is a much more useful process for if my code is not working, because I can watch my variables as I step through one line at a time and then keep an eye on them and figure out when they start drifting off track. And then I know that that's the line of code that's got a problem that I need to focus on to fix whatever problems are happening. The good news about this debugger is that it works with Spring as well. So if I have a handler for a particular route running, I can set a breakpoint in that handler, visit the route in my browser, and the breakpoint will still trigger, and I can step through the handler and see exactly what's happening as I visit that particular route. So if you have a page that's not displaying properly, it has the wrong information, doesn't access things in the way that you expect, you can still use the breakpoint even with Spring to help you figure this out. I didn't even get to show you what step into and step out of can do. Those are more useful when we have meaningful method calls, which we only have one method here, which is main, so I can't really do much with those for this particular example. But tonight, Studio, we might be able to do a little bit more work with that, because you'll be writing a few more methods for today's Studio. Yeah, does anybody have any questions? So this is Unit 3, right? We've got about 5 weeks left, and so, or 6, I can't remember. And so one of the things that I really want to stress to you before this class over is how to solve problems on your own as much as possible. Because the fact of the matter is that as much as I love working with you all, I won't always be around to help you out with your stuff when you get stuck. Your TAs won't always be around to help you out with your stuff when you get stuck. As much as it pains me to do it, I'm gonna have to start pushing you guys out of the nest a little bit and hoping that you know how to fly, which I'm sure you all can do. I'm very confident in your ability to do that, but I want to make sure that with the remaining time that we have, I show you as many skills as possible to be able to help figure out your own problems. Because that's what's going to be expected of you in a professional environment as well. Not necessarily that you're going to be able to fix every single thing that comes your way, but people are certainly going to expect that you at least attempt to, and that you've taken steps, and they're going to want to know what kinds of things you've tried to fix the particular problems that you run into before you ask for help. And so I'm going to spend some time over the next few weeks trying to highlight some things. The debugger is one of your best friends for this purpose. And so that's something that I'm going to try and enforce now with these assignments. In particular, if you come and ask me for help, one of my first questions to you is going to be, well, did you try to run it through the debugger? I hope the answer is yes, and if the answer is no, well, I might sit down with you and work through it with you using the debugger a few times until you get the hang of it, because it's an important skill to have. But if there aren't any more questions, I think that's going to wrap it up for today. You do have a studio to work on. You also have that Tech Jobs assignment, which is due on Thursday. So use your time wisely. We will regroup as we usually do at 8 o'clock and go through the studio. So I'll see you all then.